Let's solve this kinematics problem involving derivatives. We have a particle p moving in a straight line, where its displacement s is given by 4t minus 4 cosine of 2t plus 4, where t is in seconds and all lengths are in meters. Let's start with part A, finding the velocity. Remember that velocity is the derivative of displacement with respect to time. So we need to differentiate this equation term by term. The derivative of 4t is 4, and for the cosine term, we use the chain rule. The derivative of negative 4 cosine of 2t is 4 sine of 2t times 2, which simplifies to 8 sine of 2t. Now, let's find the acceleration. Acceleration is the derivative of velocity with respect to time. Taking the derivative of our velocity equation, the derivative of 4 is 0, and the derivative of 8 sine of 2t, using the chain rule again, is 16 cosine of 2t. For part D, we need to find when the acceleration is 0 between 0 and pi. Setting our acceleration equation equal to 0, 16 cosine of 2t equals 0. This means cosine of 2t equals 0. In this interval, this occurs when 2t equals pi over 2 and 3 pi over 2, which means t equals pi over 4 and 3 pi over 4. Finally, let's sketch the velocity time graph. We'll create axes from 0 to pi on the t-axis, and we need enough room on the v-axis to show all values of the velocity function. The velocity function is 4 plus 8 sine of 2t. Let's identify some key features. At t equals 0, the velocity is 4. At t equals pi, the velocity is also 4. The maximum velocity is 12, occurring when sine of 2t equals 1, and the minimum velocity is negative 4, occurring when sine of 2t equals negative 1.